All right, let's talk about the exponent rules. Okay, so for these, we're going to be simplifying them or writing them in a new way. So we're not actually doing 5 squared, which is 25 times 5 to the 7th power, which would be 5 times. I don't want some giant answer here. What we're doing is simplifying this. So the bases are the same, so they're going to stay the same. And then the exponents, because exponents always like to be a little lazy, so they always do the easier version of whatever you're doing. So the easier version of multiplying would be addition. So they're 9. Okay? Division, okay, again, the bases are the same, so they're going to stay the same. And then the exponents are different, so they're going to react like an easier version of division, which is repeated subtraction. So this is going to be subtraction. So this is going to be 5. 8 minus 3 gives me the 5. Now, 5, let's do this one next, these two next. So 7 to the 3rd, and that is to the 4th power. Okay? So in this situation, you don't have to do 3 times 3 times 3 times 3. You would just multiply the exponents, causing this answer to be 7 to the 12th. Now, the exponent -1, negative means that this is the numbers are in the wrong place. So if 2 is in the wrong place and 3 is in the wrong place, because the parentheses tells me that the negative goes to both of these. So the correct answer would be 3/2. Now they're all in the right spot. Now what about this, Mr. Casters? There's only one spot. There's only the 5. So how is it in the wrong place? Well, you can turn anything into a fraction by putting a 1 underneath it. So now you have a 1. So this is going to be 1/5. Okay, yeah, the 5 moves down here, but you can't leave the top empty, so you put a 1 there. Okay, here. So this is my version of, instead of just simplifying, you're just going to know that it's equal to each other. So 2/5 squared is the same thing as writing 2 squared over 5 squared. Okay, this one here. Okay, now this time the exponents are the same, so those are going to stay the same. When the bases are different, you literally just multiply them like it says. So 9 times 3 is going to be 27 to the 3rd power. This one here. So again, the exponents are the same, so the exponent is going to be 5. And these numbers are going to actually do what it says, 12 divided by 4, which is 3. 19 to the power of 0, everything to the power of 0, except for 0, equals 1. Okay? Now let's shift up, scientific notation. So I'm going to convert this into something that looks similar to this. I'm going to convert this into something that looks similar to this. So let's go over that. So you're going to stop after the first number, and you're going to make the upside down t. We're going to round this. This is us doing scientific notation and rounding because we're estimating. So does the 7 do anything to the 3? Yes, the 7 is one of the 5 numbers that actually do something. So this is going to turn into a 4. So that's going to be 4. The times 10 is always going to be there. And now we have to figure out what the exponent is. The exponent is going to be all of the numbers behind it, and you stop at the decimal point. Now, I know this doesn't have a decimal point, but just in case it is money and they have a 0.00, I'm going to say that. So it's going to, how many numbers do I have behind here stopping at the decimal point? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's going to be a 9 right here. This one's the same thing. We make the upside down t to check rounding after the first number that is not a 0. So it's going to be right here. Does a 2 do anything to the 5? Nope. So that's going to be just a 5. We rounded it. Now times 10. Now this one is actually going this way. So it's going in the opposite direction. We're going to stop at the decimal point. So this is going to have 1, 2, 3, 4, 5, 6. It's going to have 6. Now there is a difference between these. This is a very large number, and this is a very small number. Okay? So just to tell you that it's a small number, because I wouldn't know from you sending me this, you're going to put a negative sign next to the exponent, telling them it's going to be a very small number. So everything in math, you need to be able to do it forward and in reverse. So that's what this is. So we're going to be turning 3.2 times 10 to the fourth. It should just be 3 because it's rounded, but we'll practice doing it actually like this. So it's going to be 3.2, and the decimal point, there should be 4 numbers behind it. So there should be 1 number here, 2, 3, 4, and that's where the decimal point should be. So I need 3 zeros to finish that off. It's going to be 3, 2, 0, 0, 0. Okay? Normally, when you're rounding, it would just be 1 number here, a 3 or a 4. Like this should just be a 7. So let's do them with just a 7 there. So there's a 7, and there should be, now -3 means the numbers should be on that side. So there should be 1, 2, 3 numbers over here on this side. So 0, 0. So this is 0.007, 007 action right here. All right, so let's go to one that doesn't round. So we're going to shift right here. So we're not rounding this. We still make the upside down T behind. Okay, but this time you don't round. That's just telling you know where the marker is. So now you still write 3.76. Okay, because those are all the numbers. I'm not going to include the zeros. You'll still multiply by 10, and you're still counting all of the numbers up to the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it says 9. So even though it looks a little bit more complex, it's actually less work because I didn't have to round. Same thing over here. I still make the upside down T behind the 4, but this is now going to be 4.21 times 10, and now how many numbers are behind the decimal point? 1, 2, 3, 4. It's going to be -4. All right, one more time. We're going to do 2 of these. Actually, I've already done that one unrounded. Actually, I've done this one already unrounded, so we're going to skip this one. We're going to do this one. So remember, you have 6.13, and we're going to the left 5 times. So 1, 2, 3, 4, 5. So here's my new dot, and I need 4 zeros here. So my final answer is that. That's how this originally looked like. This is the standard form. This is the scientific notation. Now, many calculators write scientific notation like this, 6.2 E6. This is actually the same thing as writing 6.2 times 10 to the 6, which is the same thing as writing 1, 2, 3, 4, 5, 6. 6, 2, 1, 2, 3, 4, 5. 6,200,000. And that's it.